Hi students, welcome back to my channel Evolve Solving Physics. Today we are going to discuss two topics, that is equilibriant and Lami's theorem. So what is meant by equilibriant? It is negative vector of the resultant of number of vectors is called equilibriant. So by simple example you can easily understand what is meant by equilibriant. So equilibriant is denoted as E bar. So for suppose F1 bar, F2 bar and F3 bar are three forces acting on the body. So the resultant vector will be resultant vector, that is resultant force is Fr bar is equal to F1 bar plus F2 bar plus F3 bar. So this is the resultant force. So how we will get the equilibriant means equilibriant is denoted by E bar, that equals to minus Fr bar. So the equilibriant will be equal to the resultant force which having same magnitude but in opposite direction. So equilibriant will be equal to negative vector of the resultant of vectors is called equilibriant. So you can see here what is equilibrium means negative vector of the resultant. So this is the negative vector of resultant. This will be equal to number of forces, that is number of vectors, that is equal to equilibriant, that is called equilibriant. Equilibrium will be equal to the resultant force or resultant vector having same magnitude but in opposite direction. So the resultant vector or resultant force will having same magnitude with the equilibrium but in opposite direction. So this will be equal to, so this can be said as negative vector of resultant of number of vectors is called equilibriant. So E bar is equal to minus of Fr bar means F1 bar plus F2 bar plus F3 bar. So just remember that negative vector of resultant of number of vectors will be called as equilibriant. So negative vector of resultant of number of vectors will be equal to the equilibriant, that is E bar is equal to minus Fr bar. So to keep the particle in equilibrium, how many forces does we require? So single force can't keep the particle in equilibrium. So you should remember that no single force can keep the particle in equilibrium. So minimum number of forces required to keep the particle in equilibrium is 2. That is minimum number of equal coplanar forces. Equal coplanar forces means the forces which lie in a same line, in a same plane. So equal coplanar forces require a minimum number of particles is 2. So minimum number of equal coplanar forces required to keep the particle in equilibrium is 2. Minimum number of unequal coplanar forces required to keep the particle in equilibrium is 3. So unequal coplanar forces required to keep minimum the particle in equilibrium is 3. So equal coplanar forces, minimum number of equal coplanar forces required to be minimum number of equal coplanar forces required to keep the particle in equilibrium is 2. Minimum number of unequal coplanar forces required to keep the particle in equilibrium is 3. So that are the minimum forces required to keep the particle in equilibrium. So minimum number of equal or unequal coplanar forces required to keep the particle in equilibrium is 4. So as we discussed, the 3 points means single force can't keep the particle in equilibrium. We require minimum number of equal coplanar forces to keep the particle in equilibrium is 2. minimum number of unequal coplanar forces required to keep the particle in equilibrium is 3 if the forces are equal or unequal coplanar forces. So if the forces are equal or unequal coplanar forces, minimum forces are required to keep the particle in equilibrium is 4. So these are the 4 main important points to keep the particle in equilibrium. So these are the 4 important points how a particle can be in equilibrium. Next we are going to discuss about Lami's theorem. So what is meant by Lami's theorem? What is the statement for Lami's theorem means? If 3 coplanar forces acting at a point keeps it in equilibrium. So I said that coplanar forces means acting in a same line or acting at a same point. So all forces acting at a same point means that particle will be in equilibrium. So just remember that coplanar forces means all the forces are acting at a point or lying in a same plane or same point. When the particle will be in equilibrium means all the forces should act at a same point having same magnitude, but that should be in opposite direction. So what is meant by Lami's theorem means if 3 coplanar forces acting at a point keeps it in equilibrium. So any vector, any number of vectors are acting at a same point means that all the vectors will keep the particle in equilibrium. We have already discussed in previous class that number of vectors acting at a point at a same point means at that point the particle will be in equilibrium. Here the 3 forces are acting at only at one point. At one point the particle will be in equilibrium. So that keep the particle in equilibrium. Here the 3 coplanar forces are acting only at one point. That is here O. These 3 forces will keep the particle in equilibrium. Then each force is proportional to sine of angle between the other 2 vectors. So here the 3 forces are acting at same point that keep the particle in equilibrium. Here each force is proportional to the sine of angle between other 2 forces. So here F1 is the force that will be proportional to sine of angle between other 2 forces. So F1 force will be proportional to sine of angle between other 2 forces that we discuss here. So what is this diagram? You can easily understand what is Lami's theorem. So you can see here F1, F2 and F3 are magnitudes of forces, and F1 bar, F2 bar and F3 bar are forces, vector forces. Bar represents vectors. Just F1, F2 and F3 represents magnitude of forces. Here alpha is the angle. Here alpha is the angle between which forces? F2 and F3. So alpha is angle between F2 bar and F3 bar. You can see here alpha is the angle happened between F2 bar and F3 bar, and beta is the angle happened between F3 bar and F1 bar, and gamma is the angle between F2 bar and F1 bar. So you can see that here the angles are happen between 2 forces. So how you can write according to Lami's theory with the help of these angles? How a Lami's theory can be defined as? According to Lami's theorem, F1 bar by sine alpha. Why I am writing according to Lami's theorem F1 bar by sine alpha? I said that force is proportional to sine of angle between other 2 forces. You can see here each force is proportional to sine of angle between the other 2 forces. So F1 bar by sine alpha. You can write it as f1 bar is proportional to sine alpha. Why I am writing sine alpha only? Here alpha is the angle between f2 bar and f3 bar. Angle is happened between f2 bar and f3 bar means this angle will be proportional to f1 bar by sine alpha. So I said here in statement that each force is proportional to sine of angle between other two forces. Here f2 bar and f3 bar are forces happen between the angle alpha. So this sine of angle alpha will be proportional to f1 bar, that equals to f2 bar. So f2 bar, f3 bar and f1 is the angle happen for beta. So f2 by sine beta. So f3 bar by sine gamma. So alpha is the angle happen between f2 bar and f3 bar. So the sine of alpha will be proportional to f1. So f1 bar by sine alpha. f1 here. Each force means f1 force is happened here. That will be proportional to sine of angle between other two forces are f2 and f3, and sine of angle is alpha. So f1 will be proportional to sine alpha. That can be written as f1 by sine alpha. And similarly f2 bar by sine beta, that equals to f3 bar by sine gamma. So what is Lami's theorem means? Considering three coplanar forces that keep the particle in equilibrium, and each force will be proportional to sine of angle between other two forces. Here alpha is the angle happen between f2 bar and f3 bar. Here missing force is f1. So f1 will be proportional to sine of angle, that is alpha, happen between other two forces. So f1 bar by sine alpha, f2 bar by sine beta, that equals to f3 bar by sine gamma. So this is about equilibriant and Lami's theorem. So if you have any doubts, please comment me in comment box. Please like, share and subscribe my channel. Thank you.